Therac-25. The Therac-25 was a computer-controlled radiation therapy machine developed in Canada during the 1980s. It was designed to treat cancer by directing powerful beams of radiation at tumours. Earlier machines used physical safety locks, but the Therac-25 relied more heavily on software. A hidden programming error allowed certain commands to place the machine in a dangerous state, producing radiation doses far beyond the intended level. Several patients were seriously injured, and some later died. The accidents became an important warning about trusting software without independent safety systems, especially when a machine can directly affect human life. SL-1 Nuclear Reactor. The SL-1 was a small experimental nuclear reactor operated by the United States Army in Idaho. It was built to test whether compact reactors could provide electricity and heat at remote military locations. In 1961, a central control rod was pulled out too far during maintenance, causing an almost instant surge in power. The reactor exploded, killing all 3 workers inside the building. Investigators found that a single control rod could produce a dangerous change in the reactor's behavior. The accident influenced later reactor designs by showing the importance of preventing one action or one component from causing a complete disaster. RBMK Nuclear Reactor. The RBMK was a Soviet nuclear reactor designed to produce large amounts of electricity while also allowing fuel to be replaced during operation. Its enormous size and relatively low construction cost made it attractive for the Soviet power system. However, the design could become unstable under certain low-power conditions, and its control rods had features that could briefly increase power when first inserted. These weaknesses contributed to the 1986 Chernobyl disaster, when a safety test led to a sudden power surge and explosions. Later RBMK reactors received major safety changes, but the original design remains closely associated with the dangers of poor engineering decisions and weak safety culture. Windscale Pile. The Windscale piles were early nuclear reactors built in Britain after the Second World War. Their purpose was to produce plutonium for the country's nuclear weapons program. The reactors used graphite to control the nuclear reaction and air to remove heat from the core. In 1957, fuel inside one reactor caught fire during a maintenance procedure intended to release stored energy from the graphite. The fire burned for several days and released radioactive material into the environment. Operators eventually controlled it by using water, despite fears that this might cause an explosion. The accident revealed how difficult it was to manage early nuclear technology with limited instruments and incomplete knowledge. Project Pluto. Project Pluto was an American Cold War program to develop a nuclear-powered cruise missile. Its proposed ramjet engine would have used an unshielded nuclear reactor to heat incoming air and create thrust. In theory, the missile could remain airborne for a very long time, fly at low altitude, and carry several nuclear warheads toward different targets. The reactor's exhaust and radiation would also have contaminated areas along its route. Ground tests proved that the nuclear ramjet concept could work, but no complete missile was built. The program ended in 1964 because conventional missiles had improved and the political, environmental and military risks were extremely high. Tsar Bomba. Tsar Bomba was the most powerful nuclear explosive ever tested. The Soviet Union detonated it above Novaya Zemlya in 1961 as a demonstration of its Cold War weapons capability. The bomb released energy equal to roughly 50 million tons of TNT, creating a fireball several kilometers wide and a shockwave that traveled around the world. Its design had originally allowed an even larger explosion, but the power was reduced to limit radioactive fallout and give the delivery aircraft a better chance of escaping. Tsar Bomba was far too large for practical everyday military use, yet it showed the extraordinary destructive scale that nuclear weapon engineering had reached.